Welcome to our presentation on S&P USA's PV-DEDPV dryer booster fan. We're going to talk about how it can be applied and how it can be used to increase design flexibility in multifamily, mixed-use projects, and many other applications. So for the next 10 or 11 minutes, we'll have some introductions. We'll tell you about S&P USA and who we are. And we'll discuss the product, its components, how it's applied, and all the details as far as installation, the orientation. I'm Jeff Ledsinger. I'm the Central Regional Manager for S&P USA, based out of Houston, Texas. And my co-presenter is Daniel Grabb. Daniel is S&P USA's Residential Product Manager and the one most responsible for this product and its design characteristics. S&P USA is part of Solar and Palau Ventilation Systems, basically the world's largest fan manufacturer, over 80 subsidiaries, 20 different factories. Our factory is in Jacksonville, Florida, and that's the front end of our building right there. So, what is it? What is the PV-DEDPV? Well, it's part of our dryer booster fan series, with a notable exception. It is a dedicated power unit, hence the DED in the name. And Daniel's going to go into a lot of detail on what that means here momentarily. So, Daniel, why do we need this PV-DEDPV?
So that's a great question, Jeff. To answer that, let's talk a little bit about the application. So historically, laundry rooms have been located along the exterior walls, allowing for short and simple duct runs. However, changes in design trends and the growing popularity of mixed use and multifamily buildings have moved dryers further into the buildings, creating longer and more complex duct runs. So why are long and complex duct runs problematic? They provide increased pressure resistance on the dryer, which can lead to a reduced air velocity throughout the ductwork, which increases the chance of lint buildup along the dryer walls, which subsequently increases the risk of fires. The maximum recommended equivalent length of ductwork by the 2012 through 2021 International Residential Code, or IRC, is 35 feet. And that's just due to these hazards. And just to put a statistic to this, in 2010 through 2014, there were 15,970 home fires that involved clothes dryers or washing machines. And out of those, 92% of them originated from the dryer. By contrast, using a DEDPV in a closed dryer system, duct runs can be extended up to 120 feet, which is cool that that's longer than the wingspan of the Boeing 737 that I rode to come here to the convention. So now we're going to go over the features of our PV-DEDPV product. As you can see, there's a lot of important features, so they're designed for simple and straightforward installation. I'm going to start with the pressure sensor. It includes a pressure tube and a rubber grommet, and it's to penetrate the ductwork in between the fan and the dryer. The LED indicator panel is the next feature. It provides vital feedback to the building occupant of the PV-DEDPV operational status. Then we have the 6-foot power cord. Provides easy installation without the need for hard wiring. The factory power cord comes with the strain relief bushing, which was subjected to a safety test to ensure no stress on the electrical terminals will be put on the fan. Then we have the galvanized steel construction of the fan, provides robust heavy-duty performance. Then next we have the 50-foot communication cable that runs in between the printed circuit board of the fan and the LED light indicator on the wall. There's 4 duct clamps for easy removal of the PV-DEDPV system for cleaning and maintenance. while only needing a simple Phillips head screwdriver. And in addition to these features you see on the slide, the fan also comes with a robust mounting bracket whose integrity actually was tested during the PV-DEDPV safety testing with UL to ensure robust and secure mounting for the occupant in case of incidental hitting of the fan or loading that the fan might see just through everyday use. In addition to the structural integrity, mounting orientation of the DEDPV matters, and we provide clear instructions in the IOM prescribing the proper mounting orientation of the PV-DEDPV that ensures reliable pressure sensor operation. Essentially, you want the pressure sensor, the longitudinal face to be perpendicular with the ground. So I'll show you what that means in the next slide. So here's the pressure sensor body. That just needs to be perpendicular. The plane of this needs to be perpendicular with the ground, so the diaphragm of the pressure sensor doesn't have to work against gravity. But you may still be wondering, how does the PV-DEDPV work? So let's start with the sensor. It senses pressure from the slightest buildup from the dryer. The required pressure to activate the sensor is only 0.08 inches of water column, and it needs to be sensed for a duration of 10 seconds. This 10-second criteria helps to eliminate the nuisance tripping from the fan backing, nuisance tripping from wind backing into the duct line, or fluctuations of pressure inside the building pressure boundary. Upon sensing pressure, the PV-DEDPV is triggered to operate throughout the entire drying cycle. When the drying cycle is over, the PV-DEDPV will run for a delay of 5 minutes to provide a cool down period, which helps prevent flash fires in the duct system relating to high temperatures and low air velocities that sometimes can occur soon after the dryer turns off. The LED light indicator is the next feature, and it will glow green when operation is in normal range. Conversely, the LED will flash red in sequence, indicating abnormal operating conditions, such as lint blockage in the ductwork, lint buildup upon the impeller, and excessive temperatures over 196 degrees Fahrenheit are all possible abnormal operating scenarios. The features of our LED indicator panel provide valuable feedback to the occupant or building owner, offering peace of mind knowing their dryer exhaust ductwork and fan is free from lint buildup on the impeller, blockages inside the ductwork, and excessive temperatures. In other words, it quote-unquote talks to the building occupant. The UL 705 rating of this product provides confidence knowing that they are using a certified dryer exhaust product. This is of paramount importance given the harsh conditions of the dryer exhaust application. In addition to these points that you see on the slide, there's also a single shot 196 degree Fahrenheit thermal fuse for fire safety. And then we have to talk about air movement. That matters greatly in the dryer exhaust system. So the PV-DEDPV is designed to maintain a minimum air velocity of 1,200 feet per minute and a maximum of 2,200 feet per minute, and to maintain that velocity range up to a maximum of 120 lineal feet of ductwork. When installing, we recommend, but not just us, the IRC and UL 705 DEDPV standard recommends installing in 4-inch smooth dryer ducting should always be used, and the ducting should be installed using rated tape or band clamps. Screws should never be used as they can catch lint moving through the ductwork. And then we need to talk about the proximity of the fan to the dryer. It's of critical importance. The DEDPV should not be installed less than 5 feet or more than 40 feet from the dryer outlet. The maximum distance criteria is to help ensure the DEDPV will acutely respond to dryer fires by shutting off prior to moving the flames further downstream inside the duct. The certifications that we have are the HVI and AMCA certified air performance, and then of course the UL 705 DEDPV safety certification. So those are the product details, and now I'm going to turn this back over to Jeff to close out the session.
You can see there's a wide variety of building types where the DEDPV can be used, where it can be installed, and where it helps the designers do things with the building that they normally couldn't do before this type of product. Some of the most common building types are mixed-use multifamily or traditional residential buildings, either one. And there's a lot of other applications as well.